In this video, you will learn how to write formulas for covalent molecules and how to name covalent molecules. Now first, remember what covalent molecules consist of. Covalent molecules consist of elements that are all non-metals. Now when we name covalent molecules, we need to use prefixes. What's a prefix? A prefix comes before the word. In this case, we're going to use the following prefixes: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. All of these will come before the element name. Mono means 1, di means 2, tri means 3, tetra means 4, penta means 5, and etc. These prefixes indicate how many atoms are present for that particular element. So when we name, a prefix is needed for the first element when there is more than one atom for the first element. So we never begin with mono if there is only one atom for the first element. For example, we say carbon monoxide, not monocarbon monoxide. For the second element, you always need a prefix. Even if there is one atom for that second element, you will need to use a prefix. And the ending for the second element will always end with "ide." So the ending for the first element does not change. However, the ending for the second element will always end with "ide." So let's take a look at the endings for the following elements. We're going to drop the last part of nitrogen, and nitrogen will turn into nitride. Oxygen turns into oxide. Fluorine is fluoride. Phosphorus is phosphide. Sulfur is sulfide. Chlorine is chloride. Selenium is selenide. Bromine is bromide. And hydrogen is hydride. Notice that we're only talking about the nonmetals here. We're only changing the ending for the nonmetals. This will also be the case when we talk about ionic compounds. So make sure you are familiar with these endings. Again, the endings change for the second element or the second part of the name. So again, let's use these prefixes to name the following molecules. The first example we have is As2O2. You do need your periodic table so that you can look up the name of these individual elements. So here you see that the subscript tells you how many atoms there are of that element. Right? So the 2 here, As2, indicates that there are 2 arsenics, and the O2 indicates that there are 2 oxygen atoms. So in the name, we use the prefix first to indicate the subscript. So we have di-arsenic, di-oxide. So again, the 2 is represented by the prefix di, and then you name that element arsenic. As is arsenic. And then the next part of the name, 2, di for 2, and oxygen would change into oxide because that's the second part of the name. Okay? Couple of things here. Notice that there's a space between the first part of the name and the second part of the name. And again, the ending is not dioxygen, but it's dioxide. So again, we don't change the first part of the name, we only change the second part of the name. Let's take a look at the next example, Ni3. How many nitrogen atoms are there? There's no subscript, right? So what does that mean? It means that there's only one nitrogen there. Okay? So 1 nitrogen, and how many iodines? 3 iodides. Now remember the rules. You never begin the name with mono. Okay, so for that first part, you never begin with mono. You just simply write the name nitrogen, and then the second part is triiodide. So this name is nitrogen triiodide. Take a look at the third example with me, CO. How many atoms are there for carbon and how many for oxygen? There are no subscripts, which indicate that there's 1 carbon and 1 oxygen atom. Now remember, you never begin the name with mono. So just like the previous example, we're not going to say monocarbon. Instead, it'll just simply be carbon. And then how will you name the second part of the name? The second part of the name always needs a prefix. Always. So CO is carbon monoxide. Now notice here that I did not put the 2 O's next together so that this is monoxide. If I put the 2 O's together, then it would be monoxide, right? So we want to stay away from that. So it's just 1 O here for monoxide. Go ahead and pause the video here so that you can take the time to complete the rest of these practice problems. Refer to the rules to help you name your covalent molecules. Now let's learn how to write formulas for covalent molecules. To write a formula for covalent molecules, again, all you need to know are the prefixes and the numbers that they represent. So let's take a look at our first example, trinitrogen tetraoxide. Now I split this up into 3 steps. Eventually you'll get to a point where you don't need all these steps. You'll be able to go from name straight to formula. So even while you're doing the practice problems, you can actually eliminate the middle 2 boxes once you're comfortable. So let's take a look at the first example, trinitrogen tetraoxide. What are the 2 elements that you see? You see nitrogen and oxide. Nitrogen is represented by the symbol N. Oxide is represented by the symbol O. Remember that oxide is really oxygen. Now let's take a look at the prefixes. Tri. What does tri mean? Tri means 3. It means that there are 3 nitrogens. You're going to write that number as a subscript, so N3. What about oxygen? Tetra means 4. 4 oxygen atoms, O4. Now, your final step is to simply bring these 2 symbols together, no spaces, so we write it as N3O4. Let's take a look at the second example, carbon dioxide. We see that the 2 elements that carbon dioxide consists of is carbon and oxygen. Now, is there a prefix in front of carbon? No. So what does that indicate? It means that there's 1 carbon atom. Remember that you never begin with the name mono, so you will never see that here. Okay? So carbon is C1, dioxide is O2. Now again, our final step is to bring these together, and we're actually not going to write the 1, right? We've never seen the 1 written in the formulas in all of your examples that you have. You've never seen the 1 written, so you get rid of the 1 and it's CO2. When you write the element symbol, for example here, carbon, it's already indicating that there's 1 there, and that's the reason why you write the symbol C. If carbon didn't exist and there were 0 atoms of carbon, then carbon, the symbol C, would not even be written. So when you write the symbol C, it's already indicating that there is 1 atom of carbon there. Go ahead and pause the video here. Take the time to write the formulas for these covalent molecules. Remember that once you get comfortable, you really can skip the middle 2 boxes and can go straight to the formula column. Now you notice that 2 of the covalent molecules that you looked at today were actually just elements. They were elements written with a 2 subscript. We learned it previously, and they're known as diatomic elements. These are your 7 diatomic elements: bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. So these are your 7 elements that are diatomic, meaning 2 atoms. They just occur like this in nature. But these are also covalently bonded, so they're also known as covalent molecules. So when we name these, you can say dibromide, or diiodide, or dinitride, or you can simply say bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. On your notes, go ahead and highlight the 7 diatomic elements on your periodic table. So there are 2 ways to help you remember your 7 diatomic elements. Previously, I told you about Brinkelhoff. No one famous, not even a name, at least I don't think it's a name, not an object, not a place. Brinkelhoff is just a way to remember your 7 diatomic elements. Also, if you take a look at what you just highlighted on your periodic table, it forms a number 7. And hopefully this will help you to remember your 7 diatomic elements. Again, these elements are also known as covalent molecules.